Right away after diving in, we can see this coral reef is found in the first zone of the ocean. The euphotic zone has the most direct sunlight with the least turbidity. These factors are crucial for the photosynthesis within coral reef ecosystems. Obviously, because we are in the ocean, coral reefs thrive in high salinity levels. This explains their relative non-existence in freshwater bodies or near estuaries.
Although coral reefs are distributed all over the world, they are generally found on coasts between 30 degrees north and south of the equator, due to the amount of sunlight required for their growth. The countries these reefs are around vary in economic development. For example, some of the countries in Africa with coral reefs have stage 1 or stage 2 demographic transition. Countries with stage 1 or 2 of demographic transition are more likely to exploit coral reefs and the water surrounding them. Imagine if all of these beautiful fish around us were suddenly gone. This is a startling possibility with the overfishing and pollution of oceanic waters that occurs today. With countries a bit higher in the stages of demographic transition, such as Australia, the local threat still exists, but not with the reckless abandon seen in stage 1 or stage 2 countries. Any country, however, can benefit from ecotourism. Ecotourism can aid in the protection of the reefs while increasing the amount of steady income into a country. Bonaire is one example of a country with a lot of ecotourism. It is a country in the Caribbean islands, and they make more than $23 million of income every year with only $1 million in cost. And for you math people out there, that's $22 million of profit each year.
The coral reef we are swimming in right now is a Great Barrier Reef found in the Red Sea off the coast of Egypt. Barrier reefs form a boundary between the ocean and the shoreline. Other common reef structures include the atoll, which is a circular reef with a lagoon in the center, and the fringing reef, which hugs the coastline with no large water body in between it and the land. Can anyone guess what problems this could cause? I think I heard the right answer.
I definitely heard the right answer.
If you said that this causes the fringing reefs to be at an increased risk of pollution and runoff from human activity, you are correct.
Pollution is one of the 3 extremely harmful threats to coral reefs. Pollution can occur due to the deposition of waste and other inorganic materials into the ocean. Air pollution is also absorbed into the ocean. All of this can lead to ocean acidification. Ocean acidification also occurs with climate change, when increased CO2 in the atmosphere is problematic because the ocean absorbs about 1/3 of the excess CO2, leading to a more acidic ocean. Climate change causes the rising of water temperature, which stress coral polyps, causing them to lose algae, or zooxanthellae, that live in polyps' tissues. This causes coral bleaching because the algae give the coral their color. After the algae is lost, the color turns white. It is also good to know that bleached coral is not dead, but it is under greater stress, is less resistant to other threats such as disease, and therefore mortality. For a coral reef to grow, it must produce more limestone than the ocean erodes away. Ocean acidification slows the rate at which coral reefs can produce calcium carbonate or limestone, thus slowing coral reef growth.
Excuse me?
Yes, sir, in the back?
I have a question.
Go ahead.
So, I was listening to the news the other day, and I heard that the Great Barrier Reef off the coast of Australia is dead? Is that true?
So, certain parts of the Great Barrier Reef are dead, but there are other parts that are still alive, which means there's still hope for the Great Barrier Reef. Because there is a certain amount of time, 6 years in fact, that bleached coral just appears dead. But after 12 years, it can regroup and recover from that amount of stress, and it can go through secondary ecological succession, and the coral spawns over the top of the dead reef. and can replace the old reef. Primary ecological succession also occurs when an erupting volcano's lava destroys all existing plant life. Coral can grow over the top of the lava and can colonize the previously uninhabitable territory. In this way, they are pioneer species. They give the chance for new life to begin. Invasive species such as the lionfish are also a huge threat to the biodiversity of the coral reefs. It can happen in a variety of different ways. It can happen through commercial shipping, such as cargo vessels, fishing boats, and towed platforms. They can also come to the different coral reefs through the ballast water. Ballast water is used to stabilize cargo ships, and it is released in different areas. So if a fish gets into the ballast water, it can be released in tons of places all over the world. They are also in vessel hulls and fishing gear and debris. They can be released through recreational boating, and they can also be released through accidental release of target and non-target invasive species, and then the intentional release either by the government or avid fishers who just can't take care of the fish anymore. The abandoned nets are also a big part of the reason why these fish get spread all over the world. They get caught in the nets and transported to different locations, and then they are released, and they can create a threat to the biodiversity. Invasive lionfish are outbreeding, outcompeting, and outliving native fish and other marine species. They are highly considered to be one of the fastest breeders in the Western Atlantic basin. Female lionfish can produce up to 2 million eggs a year. Lionfish are also highly adaptable, settling into almost any habitat. Lionfish are also able to eat almost anything they can fit into their mouths. Scientists have cataloged over 70 species that lionfish can eat.
Now that we've taken a close look at how coral reefs are being affected by both natural and human actions, let's really dive into what a coral reef is and what makes it such a biodiversity hotspot. The first trophic level is dominated by foundation autotrophic species like the zooxanthellae algae and seagrass. The algae has a mutualistic symbiotic relationship with the hard corals. The algae provide the corals with energy through photosynthesis so that they can secrete calcium carbonate, which forms the coral reef structure, while the algae receive protection within the polyp in its secreted nutrients. Seagrass, on the other hand, is the only true plant within the subtidal sea. These dense seagrass meadows are used as breeding, nursing, and feeding grounds for animals like manatees, sea turtles, and even shelter for the conch and spawning lobsters. The second trophic level is dedicated to herbivores. One classic example of this is the parrotfish, which is the largest and most colorful primary consumer. It has a specifically adapted beak-like mouth to scrape microalgae from the coral surface. If these fish are over-harvested, then the algae would grow unchecked and ultimately lead to the coral reef's death. Another example is the surgeonfish, which have spiny attachments at the base of each tail, and they also have an adapted mouth with small and extremely sharp teeth for eating microalgae off the surface of the ground and coral reef structures. The third trophic level for carnivorous fish has multiple different types of apex predators. Some examples are the reef shark, which relies on its speed as a pursuing predator, or the grouper, which is an ambush predator and uses its disguise and stealth to attack its prey. Both of these predators control the balance of the ecosystem from the top down. They make fish species evolve by eating the weak or the sick, and through process of natural selection allow the fish to become fitter, and so lower fish like the parrotfish and surgeonfish can eat more algae, and as a product the ecosystem as a whole becomes more efficient and has a higher NPP. As we all know, because of the laws of thermodynamics, all matter is recycled. This is achieved within the coral reef ecosystem through decomposing bacteria and the sea cucumber. The sea cucumber performs a crucial ecological niche within the coral reef by ingesting sand and other decaying organic matter. They give off an increased pH, which helps to reverse ocean acidification, therefore creating a negative feedback loop in order to reverse the positive feedback loop of climate change. All of these specialized niches of these different organisms contribute to the extremely high levels of biodiversity within tropical coral reefs. In fact, coral reefs have only 1% of ocean space, but up to 25% of all aquatic marine life. This means 1 out of every 4 aquatic organisms relies on coral reefs in some way to live and thrive, as all organisms want to.
Around 500 million people rely on coral reefs for food, coastal protection, and livelihoods. For food in developing countries, coral reefs contribute about 1/4 of the total fish catch, providing food to approximately 1 billion people in Asia alone. Coral reefs also form natural barriers that protect nearby shorelines from the eroding forces of the sea, thereby protecting coastal dwellings, agricultural land, and beaches. More than 150,000 kilometers of shoreline in 100 countries and territories receive some protection from reefs. They are also important for medicine. Coral reefs have been used in the treatment of cancer, HIV, cardiovascular disease, ulcers, and other ailments. As we wrap up our tour and head back to the boat, I just want to thank you guys for coming, and I want to encourage you guys to go on another ecological tour, maybe not necessarily with us, but even with another country. These countries, if they get your business, they would be more likely to invest their time and money into these coral reefs.
So your vacation actually helps protect the environment.
Thanks for coming, and we hope to see you next time.